From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We've really hit on something that resonates well with companies and sort of differentiating between design for additive manufacturing and modifying for additive manufacturing. So DFAM and MFAM. And I think where that really resonates well is that DFAM is anything you're doing where you're adding value with additive manufacturing. And so, you talk about topology optimization and part consolidation, all these things are adding value and helping you make a better business case. The flip side of that coin is then MFAM. And that's all about anything you do to avoid costs with additive manufacturing. And so there are things about, build planning and support structures and post-processing and inspection, anything you're doing to modify your design to avoid all those extra costs, that falls in this MFAM bucket. And so it's become this nice sort of yin and yang of, am I adding value or am I avoiding cost? And both of those things are worthy and need attention. And it's easy to then start saying, easily categorizing all the different ways you can do and use and apply additive is like, okay, is that adding value or is it avoiding cost? And based on that, how do we move forward?
That was Tim Simpson. Tim is the Paul Morrow Professor of Engineering, Design, and Manufacturing at Penn State University. His research focuses on additive manufacturing, engineering design and optimization, and technology-based entrepreneurship and innovation. He is also part of the Barnes Global Advisors team. We talked today about the ever-evolving world of 3D printing education and training, and Tim also shares his predictions for the ongoing growth of the AM industry. Hi, Tim. Welcome to the show. Why don't we get started with a little bit of kind of your history in the additive manufacturing space? Where did you get started?
Sure. Thanks, Mike. Great to be here. Lots of other cool guests that you've been having on this. So honored to be part of that. So I guess my additive journey goes back to, almost 25 years ago, grad school now. I was at Georgia Tech doing product design development research. And they were Dave Rosen and the team was putting in this cool new, 3D printing lab, the rapid prototyping manufacturing lab there. And, that was way back with stereolithography and FDM at the time. And so saw the technology, actually helped. I did a lot of design of experiments work. So I actually helped plan a bunch of experiments on sort of optimizing process parameter settings. I mean, it's funny. It's the same thing, we're doing now for metal that we were doing, 25 plus years ago for plastics. So, I've been after I graduated, came to Penn State and, I'm again, product design guy. So we've always sort of lectured on, taught students about how to use 3D printing as part of prototyping, as part of product design and development and the impact there. And then it was really the last, almost 10 years ago now, I was putting together actually a map of campus, all the 3D printers that were scattered around. We had expanded, we had more students that could use the printers that we had in the learning factory at the time, and started meeting other groups on campus and created a network of 3D printers and digital fabrication technologies, and stumbled into applied research lab, and they had an Optimec lens system in there. I was like, holy cow, we can 3D print metal. It was like, my world just exploded at the time. Like this, whole, game changer right there. And, from there, that was about the time, right? This next wave of interest in metal additive manufacturing, everything took off. And we were fortunate with Rich Martikanitz, who was the lead on that group. He and I had submitted to DARPA's Open Manufacturing Program, and hence we launched Sim 3D. And then about a month later, I think we were part of America Makes, part of the 9 or 10 universities there, and then it was just sort of hang on for the ride, right? I mean, it just has exploded since then. So it's been fun, and so I still do product design development, but I really had to spend the last 10 years now understanding the details of the processes, the materials, standards, testing, qualification, all of this, to then help me, research in all those areas to then help inform, what do I need to teach, designers and future engineers about how best to use this. So that's hopefully a fairly short summary of, let's see, the past 25 years. Yes.
And so kind of drilling down a little bit on the education front, kind of what's your thesis, or what's you/the university's thesis on educating engineers or people coming up interested in additive? Do you view it as a kind of separate technology, or within kind of broader product design, mechanical engineering, materials engineering? Kind of are there lines being drawn? Are they blurred?
Yeah, no, it's a good question. I think certainly it's funny. You see that I do work, I'm teaching sort of the next generation engineers and students here. We work a lot with companies, doing research in Sim 3D. And of course, I'm working this year in particular, as I'm on sabbatical, working a lot with John Barnes and the team at the Barnes Global Advisor. So we're actually doing, workshops at companies. Okay, granted they're remote and virtual, but nonetheless, I'm sort of seeing that full spectrum there. And at the undergraduate level or sort of in college, I think you're using 3D printing and additive as sort of a good hook or an on-ramp to, what's this technology, broadening their minds about what can be made, why, and how to design differently for this capability. But end of the day, additive is one of many processes that are out there. And how do you pick and choose the best? And what does that mean from, performance, time, cost, schedule, those sorts of things. I guess the downside is that these undergrads and the students, they get so enamored with 3D printing that they think everything should be 3D printed, right? And so we're now having to fight that tendency, and they've got such easy access to 3D printing. I mean, heck, a lot of students are coming and already have 3D printers from high school, so now they're printing stuff in their dorm room overnight for their project the next day. And so it's everything should be 3D printed, which of course is not the case. And then you see the flip side of that in industry, right? As well, what are the risks involved? What is how far is the technology really? What's the, sort of the readiness of this? And it's, much more apprehensive and or cautious, obviously so, than when we have to teach. And so it's funny sort of sitting between those sort of the opposite sides of a seesaw, if you will, where one group is completely gung-ho, and the other group is certainly much more reserved. And it just makes for interesting, right? When these undergrads go and work in these companies, how does their excitement for the technology run up against sort of the current culture within an organization? So I think, as I said, we're trying to, how do we best prepare students to recognize this is one of many new technologies, or many manufacturing technologies. And then if and when you have the opportunity, how do you, design for additive to really exploit what you can, now do and make, since you're fabricating parts, layer by layer by layer.
So you've probably put in several cohorts of undergrads, even graduate students into industry now, and they're at many large companies scattered throughout, many companies doing additive work. And what's the kind of how, now that like people are out in the field kind of doing work, like are you having to update your teaching models, or kind of what's really important to teach? What was something I really thought was important, but less emphasis here? Or is there something that has kind of evolved over the last certainly couple of years that that you've seen?
Yeah, great question. I think I'd say certainly feedback from students on sort of, well, what are the challenges they're running into in a company, in industry, right? A lot of that ends up being they had such free access to 3D printers, for instance, that now they can't touch the one in the company, or have to go through a certain process, or find the right group to print something. I think the other thing obviously is they're so, one of the good thing about students is they don't know what they can't do, right? And so they go and have all these crazy ideas, and so now it's the the reality of the real world, right, sometimes smacks them a bit hard in the face there. I think probably what's been more impactful on my teaching is, the work that I've been doing with companies, again, with John Barnes and the team, is really, that's been seeing what companies are really struggling with, the challenges that they're running into in terms of adoption, software, workflow, cost. I think that is now I'm trying to bring more of that back into the classroom. And so we're using my own real world experiences, which doesn't always go well either, right? You gotta be careful. We can dream up anything we want in our academia and ivory towers, but I like to be very grounded in industry there. And so I think it's been very useful to be out there doing workshops, training companies, writing about it, and then I'm using that to feed back into the engineering and 3D printing courses that I teach. And so there's a much bigger push and emphasis on, on the cost modeling and understanding the cost side of it, and understanding and talking about risk, these sorts of things, which, we should be talking about, but it wasn't as tacit. It wasn't as real. You couldn't get your teeth around it as much as you can now with additive. And I think that's the other thing too, standards, right? They used to be, okay, and some people may say they're still pretty boring, but they used to be like, well, why are we talking about standards, right? Why is this relevant? But it's like, with additive, there's so many cases where we don't have the standards that now it becomes a good conversation on what's the importance of standards and why do we have standards? And okay, without the standard, what do you do, right? So it's creating all of these sort of what ifs and great discussions that previously we couldn't really have in engineering. We just sort of went with the steady state, and okay, I teach thermo, and I teach statics, and I teach dynamics, and this and that. But being in product design and manufacturing with additive, everything is so in flux right now. It's both fun and exciting, and scary and challenging at the same time.
I imagine within the Penn State ecosystem too, you're drawing, with the center being kind of Additive Focus, I'm sure you draw from all sorts of departments, all sorts of case studies, medical, maybe bio, maybe materials, like that, all that comes together. Have you seen kind of like academics that additive may not be their first thing, but like they're now considering it, kind of having these different conversations about, like there's some different approaches that we may not have considered without this technology?
Absolutely, yeah. And so I've worked hard. I was fortunate. Penn State, we take education very seriously here. We've got a great called the Teaching and Learning with Technology group. So they're funded by Penn State at the university level, and so they get sort of funding to sort of try out new technologies that then might, how does this impact our teaching? And so I think it was 4 or 5 years ago, they were just starting to think about 3D printing. So I was the 3D printing fellow for Penn State. And so part of what I did was go around and talk to, intentionally to your point, okay, let's go talk to the architects. Let's go talk to, the ceramicists. Let's go talk to the material scientists. Let's go talk to all, to the medical groups, and see where are they with additive and 3D printing, what's coming, what do they have, what would they like to do? And from that, we built a sort of a community of 3D printing experts, faculty, instructors, staff, as well, that, just sort of everybody sort of mixes and mingles nicely. And I think that's one of, the benefits of a big university. Of course, the challenge as well is we have depth, you just got to find it. Much like in a big company, right? And so in many ways we mimic, I look at like a Boeing, for instance, right? They're in Philadelphia, they're in St. Louis, they're in Seattle, they're all over the place, right? As you have these just different levels of expertise around different technologies, we've got the same thing in Penn State, right? You've got technology around ceramic 3D printing here, concrete printing there, bio printing here. And so how do you get those people talking to one another? Because additive, you can't do alone. As a mechanical engineer, right? I can only design so much. I got to know about the properties and process and that, and vice versa. And so how do you create opportunities to learn from each other across disciplines, and share and exchange ideas? So we've been doing now with COVID, we've been doing a virtual colloquium once a month where we get together and do different topics. And then we look for things like common areas of interest, like, okay, sensing. We're going to do our next one next month is on sensing. And so, like you were saying, folks that have great depth and expertise in, say, ultrasound may not have applied it to additive manufacturing, but now let's create a discussion around, hey, what, where, and how could we use ultrasound for, inspection in situ, pre-post. Let's look for new uses there. And so we're sort of matrixing, who's the technology experts at the process design materials, and then what are the application domains: aero, auto, heat exchangers, gas turbines, medical. And I sort of joke, I can keep track. Metals is my primary interest. Polymers is sort of secondary. As for bioprinting, concrete and ceramics, I can't keep up with it all, but I know who to go to if I have any questions. And so that's the way I've, sort of tackled that problem.
And from a student perspective, when they go to Penn State, do they get a degree in 3D printing, or is it kind of stratified depending, is it a minor within mechanical engineering? How's it work at graduate level? Can you speak a little bit to that?
Yeah, no, great point. So that we do not have at the undergraduate level, we're sort of infusing 3D printing even as early as freshman year. One of the things that I did helped launch was our Maker Commons. So we've got within the main library on campus 32 3D printers that now any Penn State student can print for free. And so we've now integrated those into different courses: freshman year, sophomore, junior level, the mechanical design course. There's 3D printing projects in there so they can use it. And of course, senior, capstone design. So we sort of created a backbone with 3D printing across multiple departments. At the graduate level, though, we are fortunate. We did launch a brand new additive manufacturing and design degree. So it's a master's. It's both online and resident. So if you are a resident student doing research, you can get a Master of Science online. If you're working at a company, you're taking 1 or 2 classes remotely. Come to campus for a hands-on lab and do a project, and then you get a Master of Engineering there. So we are seeing that enrollment has. We've got over 120 people now from 60 different companies enrolled in that, which is great. And that, to your point, is taught by 5 different departments. And so our core courses, we've got a class in industrial engineering that talks processes. We've got a class in material science that's AM materials. We've got a class, we have an engineering design program, so they teach design for AM and et cetera. And then you have electives here and there. So we worked with the law and business to create a legal implications of additive course, right? That talks about this. So we're able to bring that in, and you can enroll directly in that program and go through and get a degree, or you can take it as a minor. So if you are getting a mechanical engineering PhD or master's, you take 3 or 4 courses in additive, and then you also get a minor as you go. So you've got a lot more flexibility at the graduate level to bring in new courses and do things like that. Undergrad, you're still constrained a little bit by ABET, our accreditation bureau, and those sorts of things. So we've done our best to exploit that at the graduate level as much as we can.
And more high level question. So in the industry as you see it today, do you think the acceleration of machines adoption by companies, both large and small, is education keeping up with is the workforce keeping up with the industry, or is?
Yeah, good question. In some ways it is ahead, in some ways it lags, right? I think you go into a lot of the companies and it's, you certainly have experts that are in there, but it's 1, 2, maybe a handful of individuals, right? And the challenge is there now. How does it pervade? How does it become, sort of ubiquitous throughout? And a lot of times when we go into companies and do that, is thinking, okay, well, what's sort of the, what does everybody need to be aware of versus if you're, sort of the intermediate level versus if you're the additive expert. And that's, that's been challenging. The flip side from teaching students, right, as well with additive is I may be talking about this software or this process or this particular technology that, oops, that was acquired last night, or oops, that's now, completely is no longer relevant because all of a sudden company X just came out with this technology. I mean, you look at the, sort of the laser wars that are going on right now with SLM Solutions and Velo 3D and everybody, right? I've got this many, that many, sort of like, okay, well, I was still lecturing on single laser, I'm not even at dual lasers and quad lasers.
It just scales though, right? It's easy, right? It just scales. Right?
If only it were that easy, but so that's challenging. And it's, a lot of the, just the pace at which technology is changing these days, right? I mean, you look at artificial intelligence, right? Look at mobility, and 5G, these sorts of things, trying the usual model of, hey, let's create a 15-week class to teach X, right? Well, in 15 weeks, X is going to change drastically. So how do we get, shorter snippets, tidbits that are updated more in real time, taught just in time, those sorts of things is there's some potentially very disruptive forces out there, I think, when it comes to our traditional long-standing educational models.
And I imagine too, like the breadth or like the span of types of companies is really all over the board. You have it like depending on the size, like training a Boeing looks a lot different than training a company that has one, maybe two metals machines and engineers, as well as industry, right? Like it's not necessarily transferable. And so you have this huge set of, or huge problem set, but
absolutely. Yeah. And so the diversity of companies, of sizes, of industries, mapped against the diversity of technologies, material sources, et cetera. That's a pretty messy many to many mapping there. And so trying to figure out, well, what do we teach? And perhaps that's why people, I actually was just did some work and went and looked at sort of what are the most common of the courses and programs that have popped up. Penn State, Carnegie Mellon, Ohio State, Maryland, among others, Auburn as well. Actually quite a bit going on in the UK and Europe in addition to that, but you sort of look at it and, well, what's, what would you think is the most commonly taught course across all of those? I'm gonna pose that one back to you, Mike.
I'd say like business for 3D printing or some element.
Oh, that's actually there's only a couple of those. That's actually a rarity, surprisingly. Okay. No, it's the processes is the big one, right? Because that's, okay, here's our 7 categories. We've standardized it and I can, if I have a 15-week course, then I can spend 2 weeks on every process and boom, I'm good. All right, process, this
slide
tech,
number one on
lasers here.
Every intro.
Exactly.
Right? These are 7 ASTM defines 7 different
there
processes.
You go. There's well over 100 of those such courses out there, right? But that only gets you so far. What you need, what companies need in one, and what the students need in one is exactly what you said. It is the business considerations, right? Let's start from there and work backwards. But the challenge there is that the business considerations for a large aerospace company like a Boeing or Lockheed versus, a Ford or a GM in the automotive space versus, Stryker or, Tangible Solutions in the medical space, for instance, right? The quantities, the size, the regulatory, the challenges that makes those business courses, the legal courses, these other aspects, it's harder to standardize that information because there's just so much that's sort of still in flux right now.
I imagine too, like in a lot of the cases that you're working with, like people are probably tied into a system, like a machine. Like in my experience, like that's usually always like the catalyst for everything. When someone wants to spend $1 million, $2 million on machines, like so they can go show it off and bring their bosses in and show it. But then like you have all this back of okay, who's going to run it? What's the business case? What's sometimes people do that, but in most cases, like it's it's a little bit of fluff to show like someone else used it well.
Yeah.
But it's
It's extremely, and I think it's extremely challenging to make a business case for additive where you're just doing, based on your existing parts that you've designed. So if all you're trying to do is sort of, we're gonna use additive, I'm gonna AM this part instead of machine it, right? And it's gonna be a direct substitution or sort of a like for like. It's extremely hard to make a business case on that alone right now. And so you have to, in some ways you have to take a risk that, hey, the parts that we're going to be designing when we have additive are going to be cost advantageous, but I can't guarantee that now in my business case. And so it's a chicken and egg thing. And yes, you're absolutely right. Many times when you're, going to a company or talking to or doing a project with a company, it's like, yeah, we bought this powder bed fusion system, and how do I train the operator? How do I take advantage of it? How do I make money with it? Right? You sort of get stuck or locked into something there, and then you're trying to dig your way out. So, it's you see. Unfortunately, we still see far too many of those situations these days.
And kind of, you touched on a little bit of the design for additive, and I know a lot of the articles, courses that you teach focus on that. I mean, how do you see that as? I mean, it's a huge factor in getting the business model, but from both the teaching and implementing kind of DFAM in organizations, what have you seen?
Yeah, absolutely. I think again, that's sort of for me as a guy, product design, mechanical engineering background that's now also, doing think and 3D printing, DFAM, design for additive, sort of right, that maximizes the intersection in my Venn diagram on those. And so, I've been back and forth quite a bit on this in terms of, one of the nice things about teaching is you're constantly trying to find better ways to streamline what you're teaching and how you're teaching it, right? So you're getting feedback from people, both students and industry practitioners. You can, when we were in person, you could read the room and see, that's not a good look. This is I'm losing them versus sort of clarifying. And so, I think in the past 3 or 4 sets of workshops I've been doing, again with the Barnes Global Advisors here, I think we've really hit on something that resonates well with companies, and sort of differentiating between design for additive manufacturing and modifying for additive manufacturing. So DFAM and MFAM. And I think where that really resonates well is that DFAM is anything you're doing where you're adding value with additive manufacturing. And so, you talk about topology optimization and part consolidation, all these things are adding value and helping you make a better business case. The flip side of that coin is then MFAM. And that's all about anything you do to avoid costs with additive manufacturing. And so there are things about, build planning and support structures and post-processing and inspection, anything you're doing to modify your design to avoid all those extra costs, that falls in this MFAM bucket. And so it's become this nice sort of yin and yang of, am I adding value or am I avoiding cost? And both of those things are worthy and need attention. And it's easy to then start saying, easily categorizing all the different ways you can do and use and apply additive is like, okay, is that adding value or is it avoiding cost? And based on that, how do we move forward? And then you can say, all right, if I'm just trying to, replicate this existing part, right? Well, do I have the freedom to change that part? Or, can I do MFAM and try and minimize these extra costs it's going to create versus clean sheet, new design, boom, I can go all in on DFAM and maximize the value because it's a brand new part, right? And I don't have these constraints that I'm limited to. So it's been, sort of round and round and round, teaching it many times. And it seems like that was really an aha light bulb that went off just in the last couple of months here with folks. And so we're now trying to, flesh that out a little bit more and sort of, again, this sort of yin and yang on these two topics seems to really be resonating with folks.
Do you find yourself teaching it mostly designers, kind of people driving the CAD, like the actual designs, or is it a combination of you have to engage some of the, depending on the size of the organization, of course, like the operators, maybe some of the inspection, post-processing folks involved there, and kind of at various stages of the workflow, or like is everyone engaged in that conversation, or does it really drive from the designer who has to just really understand everything and be the ninja that knows like this is the how
Ooh,
this is going to run and I can't
I
do
like it, the additive ninja, right?
right.
There we go. We need to what does he or she look like, and has to do the, know everything. Yeah, no, it varies quite a bit, and I've gone from doing workshops where we're just drilling and deep diving into topology optimization and lattices and this and that, to higher level. We did one last, a couple of them actually last November and December, with program managers and project managers. And so you sort of need to be aware of what you can do, of DFAM and the processes, but you're really more concerned about what's it do to, my schedule, my cost, and performance and quality, right? So the sort of the three legs of the program manager's stool there. And so depending on that audience and others, it's always interesting when you do a mixed audience of engineers, designers, manufacturing, process engineers, throw in a few QA, QC, or testing folks, and oh man, they almost come to fist blows in some cases there, like when you put them all in a room. I think one of the more fun, one of the training sessions that I enjoyed most was actually with a bunch of chief engineers at a medical company they wanted to know what's everything that could go wrong with additive, so that they could be smart enough to ask the questions of their engineers and designers. And so that was, usually we're teaching about how to do everything right, but that was actually fun putting together a list of everything went wrong. Of course, by the end of that, they were like, well, why the hell would we ever want to use additive given everything you just told us? It was like, okay, well, okay, let's go, here's how to overcome those things, right? So yeah, it's a wide range of needs and interest there. I think the best, most productive ones, to your point, is rather than, yes, we can create the additive ninjas that, know it all, do it all, see it all. But I think more so, how do you get a team of 3 or 4, maybe 5 individuals that have different disciplines, and empower them to sort of work cohesively to consider additive from the design perspective, from the manufacturing perspective, from the materials perspective, from the quality assurance or mission assurance or testing side. And the more you can get, you don't want to be the lone person on the island. The more you can have sort of a small team to work with and look at additive from all these different angles, I think the more successful you're going to be at adopting it and advancing it within your company.
Sure. And I see that now as like kind of getting that initial design business case right, whether you're modifying or kind of designing specifically for the process. And then kind of as companies move into kind of productionizing that, I mean, there's some case studies out there that's growing.
Yep.
From a teaching perspective, do you think there's a different skill set kind of once you the design may not be as important? I mean, like that next layer, if you're going to manufacturing or kind of productionizing, scaling it, is it a different skill set that people need if they're not as focused maybe on, or they don't have as much control on the design?
Yeah, good question. I think what's certainly from let me say with respect to designers, I think, as you start to do more, topology optimization, generative design, sort of all these cool tools that are out there, your role as a designer is actually changing, right? You're not necessarily creating, sculpting, shaping the CAD model. You're defining the problem that then, the generative algorithm or the topology optimization algorithm is going to use to explore all these different design geometries, right? And so now as a designer, you're more working in collaboration with a computer, with an algorithm to, explore more options, just because, hey, I'm so used to thinking about how to design parts for casting and machining that I tend to go straight to X, Y, and Z and extrude, sweep, revolve, and that's how I do it. I think certainly what happens then with the other groups, M&P, QA, QC, testing, right? They need the awareness level versus the expertise level shifts, right? And so they may not need as much depth in how the processes work or how the laser or powder interacts and melts and what leads to a defect. They just need to sort of get a higher level sense, but then they really need to understand, okay, well, what is the impact on, of heat treatment on, microstructure and properties? Because end of the day, I'm the one who has to sign off on this, that it's not going to break, right? Or that it's going to work properly. And so, I don't think it's still evolving. What is the, sort of what are, I tend to think of it in three levels, right? Sort of what's the general awareness level, sort of the intermediate level, and the expert level. And those three levels vary depending on your role in the organization as an engineer, as M&P, quality assurance, testing, and those sorts of things. And it shifts by role and process there.
I'm sure that's even kind of expanding out, as well as like, how do different organizations, like if I'm, Boeing's probably a bad example, but if I'm a big kind of aerospace manufacturer, I'm probably not going to manufacture all the parts that I make or assemble.
Absolutely.
Right?
Yeah.
Integrate suppliers, supply chains. What level of information do I have to give them? What level of training do I need? And so it filters down, not just between person and machine or person and part, but it's company and suppliers and all
Absolutely.
that.
Yeah. And I think we're starting to see that now, right? As sort of the past 7, 8, 9 years, the big companies have been have the resources and people to invest in and understand, okay, well, what does additive mean for me, for my parts, for my company, my industry? But now they still want to then rely on the supply chain to, as you said, make, manufacture, and deliver those parts. And so how do they transfer their knowledge, their design allowables, these sorts of things, best practices with a tier 1 supplier or a tier 2 supplier or a service bureau or something like that? And I was seeing some discussion on email today around just, service bureaus that are trying to make parts for this company versus that company versus that. Standards are all over the place, and/or companies are creating their own standards. And therefore, they've got to be, a service bureau's got to be a ninja in a sense of, okay, this company wants this, but it's tweaked a little this way. And this company also wants that, but, this is different. And so it makes it challenging for them as well, which, of course, drives prices up, which then makes it even more difficult to make the business case, right? So we're shooting ourselves in the foot as part of that. So.
Okay, so as we kind of talk about supply chain, what do you think companies have to do to kind of better solve for that problem going forward and communicating kind of their design intent, their parts to a broader manufacturing supply base?
Yeah, so I think we're at a critical stage here in terms of how do we deploy and utilize the supply chain for additive manufacturing, right? And so I think one of the big things that we're not talking enough about, but you've been seeing and working in this, is sort of the whole data management and exchange side of it. And so your trace software, for instance, how does that facilitate integration across disparate companies within the supply chain, and pull those together so that you are, as you said correctly, the design intent, the design requirements, the assurances that are going on at, within the supply chain, right? From who's making the part to then who's assembling the parts to then what shows up on, your doorstep or their doorstep. So I don't think we've been focused, rightly so, on sort of the part, the microstructure, the performance, quality assurance, in situ monitoring, but we haven't stepped back and look at, what does that mean? How are we exchanging data effectively across all of these organizations within the supply chain, not within, my one particular company. And so I think we really need to broaden that discussion and be realistic about what's needed and the gaps that still occur on that front.
For sure. And you talked about data and how much learning you could probably do even just by knowing kind of how are these two machines tracking, how is this site and this site tracking with sensors or productivity, materials usage, things that like they may not be the sexiest metrics that you can use, but I think you can gain a lot of insight in terms of cost and how much does this scale and what do I have to do to improve it. So
exactly. And so I think some of the things you've developed in terms of this, having dashboards that bring all of this information, these metrics sort of together in one coherent place. I think we have that for other types of manufacturing technology, right? And we're used to doing that, and they integrate with SAP and our ERP systems and these sorts of things, but additive is still lagging in that regard. And so, I applaud you for the efforts you're doing to, engage companies in those discussions, figure out what's needed, and really try and drive that forward. Because to really productionize or really industrialize it's got to pervade the whole supply chain, and we need the design tools, we need the manufacturing knowledge, and we need the data tools as well for handling all of this.
So we're at the beginning of 2021. So if you were to be king of the additive manufacturing industry for a day, what's one problem that you'd want to kind of solve in this year?
Good question. Well, I think, the usual, the big three that always sort of pop up, and depending on the company and, who you're talking to, still, standards, remains an issue. The cost is an issue. And then I think the other big one is this, the reliance of design allowables, right? And or material properties and the information that we're used to having, that I look up in, Mill Handbook 5, this, that and the other. And those discussions are going on, they're evolving. I guess I'm biased a little bit as sort of, comes back to the design and how do we use design to really help up or speed the adoption or the industrialization of additive, right? I think we're at the point I'm excited to see, or hopeful to see, that we are, as you said, productionizing and or really industrializing. I think a lot of companies have been dabbling with it for a while. You're starting to see inroads here and there and some success stories. So I hope we can sort of shift into another gear in terms of really, really doing a good job to industrialize and, expand adoption of this technology. I think that's what I'm probably most hopeful for and or about in this coming year. So.
Awesome. And one of the other things you're working on or helping kind of put together is this Additive Around the World kind of seminar series. Do you want to talk a little bit more about that?
Yeah, no, thanks. I said earlier there, I was supposed to be on sabbatical this year. One of the nice things about academia is every 7 years we can apply and sort of go learn something new or do something new. So I had applied to go and travel the world and see where additive was really at in, companies and universities in Europe and in Asia, Singapore, New Zealand, Australia. Actually, I wish I had made it to New Zealand and Australia a while ago, right? But so since I couldn't travel, then as part of our graduate program, we've launched a seminar series. And so this spring, we're calling it Additive Around the World. And so everybody that I was hoping to go visit, I instead have invited them to speak and, virtually share what they're doing. And, fingers crossed, maybe if the world pandemic abates and vaccine works and everything, hopefully I'll get to, reciprocate and go travel and see them, 6 months or a year from now or whatever time it is. So yeah, it's been fun pulling that together. We kicked off this morning. Paulo Colombo from University of Padova, talking about in Italy, AM ceramics, and sort of what he's seeing and been doing. And then next week, actually, Mark Kirby, who was at Renishaw and is now part of University of Waterloo as their additive expert, getting their lab up and running and doing some research projects there. So hopping around a different country each week and seeing where in the world's additive. So yeah, I guess given the state of the world, that's maybe the best and safest thing we could do these days. So hopefully everybody will enjoy it.
Right. Awesome. Well, thank you so much for your time today, Tim. It was great catching up, and hopefully we'll see you in person soon.
Yeah, I hope so. Appreciate it. Thanks again for the opportunity, Mike, and good luck with everything yourself. Thanks.